Hello, my name is Rashni Panwala, and I was a part of Bio 181 Lab 00D, and my experimental design project focused on mold growth on different types of bread. So the introduction into this project, basically my main idea for this was understanding first that mold growth on bread is one of the most common producers of fungus inside of a home, particularly when you're talking about black bread mold, which is the most common type of bread mold. Um, and so in this experiment, I looked at how fungus, specifically different molds, would grow on different types of bread. And the project used 3 different types of bread under 2 different treatment methods, which included preservative level and then water presence, as well as a control that just was within the environment with no water present. And I didn't change anything about the environment other than water presence and kept it in the same area of the home during the entire project. And I looked at how the preservatives in different breads of white bread correlated to the amount of bread mold and types of bread mold that grew within a 1 month time period. And so the research question was really, will preservative presence in bread affect mold growth? And the hypothesis was that preservatives will reduce the amount of mold growth. So a little bit about background information. So a part of this was kind of looking at the pathogenicity and virulence of different bread molds. I didn't go too specific into understanding how it varies between the bread molds, but I did know that when you have a pathogenicity presence, which is overall whether or not the disease occurs or doesn't occur, that is the only way that you'll be able to have virulence, and that is the aggressiveness in the symptoms present from the disease. And when you're talking about fungus, what you're really looking for is the presence of mycelia and hyphae, like you can see on this picture here. Um, and that's pretty much what I was trying to see when I was looking for mold on the bread. And that was the only indicator I really had when trying to identify that mold. And so in order to identify that mold, I would look at color, size, shape, and then also the way that it started growing on the bread, whether or not it was clustered and moving outward from a single center, or whether it was just starting sporadically across the different types of bread. And so the most common types of bread mold that I was looking for came from these genus. Rhizopus stolonifer, which is what we would consider to be black bread mold, and you can see in this picture. Penicillium species, which is that dark green that you see. Cladosporium species, which is the light green that you see in this picture, and then Aspergillus species can have a very big range depending on the species, and they can be yellow, white, gray, or dark green. So that one is harder to kind of figure out. And it's more notably identified because it occurs from that center point that I mentioned. It spreads outward. And so another thing that I was looking at particularly was, of course, the preservative amount in the different types of bread when I originally purchased them. And so the preservatives that are most prominent in bread that keeps their shelf life is calcium propionate and sorbic acid. And calcium propionate is like is most active in the pH range 5.5 and it is common to use the acid to adjust the pH and optimize the activity. And then sorbic acid at recommended levels is in products with a higher pH level, and both are used in many chemically leavened sweet baked goods, including bread, to help counteract the pH changes in the environment so that the bread can have a higher shelf life. Um, and that's all for background information. And so the actual methods that I used in this project was first figuring out what type of bread I was going to use. And so initially I was planning on doing 3 types of bread that I would just purchase from the store. And when I went there, I realized that I couldn't find any that didn't have any preservatives in it, which I really wanted to see what the effect would be. And so rather than doing a third expensive bread, I did a cheaper option that I made from home. And so the Wonder Bread was the cheapest store-bought bread, which is bread C, and it was approximately $1.89, and it contained both sorbic acid and calcium propionate. In the Pepperidge Farm, or sorry, Wonder Bread contained calcium propionate, and the Pepperidge Farm contained sorbic acid and calcium propionate. And then for the homemade bread, that was costing about 20 cents, and that one had no preservatives whatsoever. Um, and so the first step after I brought them home was to wash my hands and make sure I didn't get any bacteria or fungus that was already on my hands onto the bread. And just for uh, understanding and background, I purchased the bread about 10 hours after I originally made the homemade bread. And so it was approximately 14 hours from me making the bread that I actually did the experiment. Um, and so after I brought them home and washed my hands, I gently took them out of their different bread bags, and I got the two end pieces so that they were similar and I wasn't wasting any bread for my roommates. And I put them inside of a clean Ziploc bag. And for one type of bread, one slice of each type of bread, I put 1 tablespoon of water on the white face of one slice of bread and then put it in the Ziploc bag. And that was going to be considered the treated slice of bread. And then I put the other one, the untreated control, in the other Ziploc bag. And I used a 1 centimeter squared grid to measure the surface area, which you do by seeing what is squares that are completely filled equal 1 centimeter, and then half filled equal half a centimeter, and less than half filled is none at all. And I measured the original surface area, which you can see in table 1. And then I checked the mold growth on each slice of bread without opening the bags using the same grid method for day 1, 3, 5, 14, and 28, which is 2 weeks and 4 weeks. And I would take the total surface area, or I would take the total mold coverage and put it over the total surface area from the original measurement and multiply it by 100 to get the percentage of mold growth. And so you can see what my results were on this slide. I was very surprised to see that I only had mold growth for bread A, both treated and control. And overall, it was a rapid increase from day 5 to day 14, and then it kind of slowed off. And I'm not sure whether it was just because the fungus started to run out of nutrients and space at that point because it was almost covering the whole bread, or just because it started to go on that decline and start to die. And so I show the calculations I used for each of the breads in figuring out the total percentage of mold coverage. And once again, there was no color difference or mold presence that I could see on bread B or bread C, and bread A showed 2 types of mold, while or bread A treated showed 2 types of mold, while bread A control showed 3 types of mold. And this is a little bit more of the images that I took in order to figure out this information. And so on the top left, you see figure B, which is at day 5 of the bread A and both bread A's, and shows a little bit of total surface area covered by mold. And then in figure D, it shows the 100% and 99% total coverage of mold on bread A. And it was a significant increase over the course of those 23 days. And then I included the original photos on the last slide, but I also wanted to show the last day that I took pictures. This includes in figure E, it includes the top bread A, bread B, and bread C, both treated and untreated, in those four photos, and you can see that there's no mold growth whatsoever. That I didn't even bother with trying to figure out, take the grid picture of it. I kind of could just look at it and know that it was 0% coverage for all of them. And so, really, what I've learned from this is that preservatives definitely affect bread shelf life. I don't think you can qualify and say that it is better in any way to have homemade bread versus store-bought bread, but if you're looking for a long shelf life, store-bought with preservatives is definitely the way to go. And then, so the results demonstrated a sigmoidal growth curve, as I mentioned, which is that S shape. And basically, what it showed is that as soon as pathogenicity was detected, virulence became more aggressive, and you could see that because of how much it grew. I also didn't see a big difference between water being present and not present. And so I decided not to make any inferences about the effects of water, but that's something I definitely want to do again and just test how water affects different types of bread and not so much if looking at preservatives. And perhaps doing this with bread that's all filled with preservatives or different values of water and see how they affect the mold growth. And so further implications of this project would include looking at whether preservatives make an effect on wheat bread or other types of bread the same way as it does on white bread, and also how non-preservative breads in general vary. So like homemade non-preservative, local bakery made, and then a chain grocery made. Um, and I know that these are things that you can get at the store. I just have to look for the correct ones. But yes, and here's my works cited slide. Thank you.